All right, guys, we're going to define and use probability. Start some probability study here, and here we go. The probability of an event is a number between 1 and 0. I guess I should say 0 and 1. That indicates the likelihood that the event will occur. So probability is the chances something will happen. Probability can be written as a fraction, decimal, or percent. And down here's a great little line to give you some interesting things about probability. If it's not likely to occur, it's going to be between 0.5 usually. If it's more likely to occur, your probability is going to be between 1/2 and 1. If probability is 1, that means it is certain to occur, like it's going to happen. If probability is 0, that means it's not going to happen. It is impossible to happen. And if it's 1/2, probably is 1/2 right in the middle, that means there's the same chance that it does or does not happen. 50-50. Having a boy or a girl. Theoretical probability. We're going to do like 3 or 4 kinds of probability today, but they're all very closely related. And you're going to feel like you're doing about the same thing on all of them, but they do have different names. The first one's called theoretical. Basically, this is like when all the outcomes are equally likely, we're going to come up with the probability that something happens. And again, it's theory because it doesn't have to happen, but that's the best guess we can make. So here's how we do it. Probability of something happening, theoretically, is the number of outcomes in the event we want to happen over the total number of outcomes. All right, so quick example over here in this picture. If this is my event, if I want to know how many, the probability of A happening, if there's 3 ways it can happen, and if you look in there, there are 8 dots altogether, there's a 3 out of 8 chance that outcome happens. Let's look at a better problem here on the next slide. Okay, you roll a standard 6-sided die. Find the probability of A rolling a 5 and B rolling an even number. Well, let's start with A, rolling a 5. First of all, there's 6 possible outcomes total when you roll a die. On the numerator, you're going to put how many of them are successes or your case or part, probability of what that happens. There's only 1 5 on a die, so I'm just going to put 1 6. So theoretically, 1 out of every 6 times you roll a die, you're going to get a 5. Now, obviously, that's just theory. Doesn't necessarily happen, but that's the probability that it happens. Rolling an even number, same kind of deal. There are 6 sides, 6 possibilities when you roll a die. There are 3 even numbers on the die. There are 1, 3, and 5. You always reduce your probability if you can, so you have a 1 out of 2 chance or a 50-50 chance of rolling an even number when you roll a 6-sided die. Okay, one more here. A community center hosts a talent contest for local musicians on a given evening. 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected scheduled to perform. The order in which the musicians perform is randomly selected during the show. A, what is the probability that the musicians perform in alphabetical order by their last name? Now, first of all, I got to figure out the total number of ways that they're, that they can select it. Now, this is what we did yesterday. How many different orders are there actually 2 days ago, orders are there of ways that you can order these musicians? Well, that's a permutation. It's just 7 factorial. So that's going to be my denominator. How many ways can you line them up alphabetically? Well, just one way. There's only one way they could be in alphabetical order. So that's going to be my probability. And if I punch in 7 factorial, it is 5,040. So 1 out of 5,040 chance that they're going to, randomly be in alphabetical order. Let's look at part B now. Part B says you are friends with 4 of the musicians. Was it probably the first 2 performers are your friends? Okay, so that turns it all of a sudden into a combination problem because we're not talking about how many different orders there are. Just you're friends with 4 of the musicians. What is it probably that the first 2 performers are your friends? This is how many different combinations of ways that you can pick 2 out of 7 people. Okay, 7C2. 4 of them are your friends. This is how many ways you can pick 2 out of your 4 friends. So again, let me go through that one more time. My denominator, 7C2, or combinations of 2, that's all the different combinations of the 7 people taken 2 at a time that there are. My numerator, I have 4 friends. That's all the ways you can take 2 out of your 4 friends. All the different combinations that can happen. So punch those in, you get 6 in the numerator, 21, reduce it because 3 goes into each one of them, 2 and 7, so it's 2, 7. So you will have some permutation combinations today because that's, again, to do probability, you have to count. So we're going to use all the methods of counting that we've already learned. All right, odds. Odds in favor or odds against an event. just same thing as probability, just written a little differently. You see odds, especially, I don't know if you watched Kentucky Derby ever or any kind of horse racing, but you see this, or odds as far as winning the lottery, stuff like that. Odds in favor of an event are this: the number of outcomes in A and the number of outcomes not in A. So it's not total number on the bottom, it is just the other parts that are not in A. Odds against A would be number of outcomes not in A over number of outcomes in A. So basically they are reciprocals of each other. Odds in favor or odds against. Let's try one, see what it looks like. All right, a card is drawn from a standard deck of 52. Find the odds in favor of drawing a 10. Okay, now there are 4 10s in the deck. So I'm going to say 4. And because there are 52 cards in the deck, there are 48 cards that are not 10. So what you do when you're doing odds is you do number of possibles in A, in case 10s, and then numbers that are not 10s, which are 48. Reduce it, you get 112. Most times they write odds like this. They'll write it with a colon, like 1 2 12 instead of 1/12. Part B, the odds against drawing a club. Okay, so there are 13 clubs, 39. That leaves 39 cards because there are 52 altogether. So the cards that are not clubs are 39. The numbers that are clubs are 13. If you reduce that, you get 3 over 1. If you write it the way they usually write odds, it's 3 to 1 odds against drawing a club. So one more time. Odds in favor, you put the number of ways you can draw 10, which is 4, and number of cards that are not 10s, 48. If it's against, you put the number of ways against on the top, 39, not a club, number of clubs on the bottom, just reciprocals. Okay, experimental. When an experiment is performed that consists of a certain number of trials, the experimental probability is given by number of trials where A occurs, total number of trials. So it's going to look the same, but it's actually based on something that's taken place. Not just theory, actual experiment that has happened. So one more slide here. Okay, the bar graph shows how old adults in a survey would choose to be if they could choose any age. Find the experimental probability that a randomly selected adult would prefer to be at least 40 years old. Okay, so at least 40 means 40 or above. So here's the number of people who are above 40. There are 551 plus 300 plus 238. All those people are, shows over 40. Now, the other thing you have to have is the total number altogether. So that means we're going to, denominator, we're going to do 463, 1,085, 879, 550, the total number, just adding all the numbers up in that table, total number of people. So that's going to be my probability that they would choose at least 40. And the way I should be doing this too, and I haven't been doing a good job in this video really, probability of at least 40, you need to write P, at least 40 years old. You need to tell in a parentheses with the P beside it exactly what you're doing so people know. People at least 40 years old. So punch those in your calculator, the whole numerator, the whole denominator. I'm going to make a little bit of room here as I punch it in. Let's see what I get. And my numerator, when I punch all that in, I get 1,089. My denominator, when I punch all that in, 3,516. And if you wrote that as a decimal, which you can always do, it'd be 0.310. So either one of those answers is fine. And that's pretty much it. Probably not a really bad day, but we are going to throw in some combinations and permutations. So we'll go over that in class tomorrow like we always do. And I'll see you then.